This is a calorimetry problem. We recognize that because there's changes of temperature in two different things. So let's keep track of that. We have things starting at two different temperatures, and they both finish at the same final temperature. So initially we have a metal that starts at 97 degrees C. It cools down to 23 degrees C, and the water bath starts at 12 degrees C. That gives us two different values of delta T. Whenever we calculate delta T, it's TF minus TI, which for the hot metal is 23 minus 97 degrees C. That results in a negative 74 degrees C. For the water bath, we start at a different temperature, but we end up at the same final temperature of 23, and we subtract our initial temperature of 12, so we have a delta T of the water equal to 11 degrees C. We now apply the first law. The energy of the universe is constant, which here means that our heat gained plus our heat lost has to sum to 0. In this situation, what's gaining heat is the cool water bath, and the piece of the unknown metal is what's losing heat. Each of these separate terms is a heat and temperature change problem, so we use the equation that heat is equal to the mass times the specific heat capacity times delta T, knowing that each of these variables is different for the water versus the metal. For the cool temperature bath, our mass is 115 grams. Our specific heat of water, I'm going to use calories. I can use this other value, but this makes the math easier, calories per gram degree C. And our delta T for the water is 11 degrees C. Okay, for the piece of hot metal, we have 47.5 grams of the metal. We're trying to determine the specific heat capacity, so we're going to solve for that. And our delta T is minus 74. These have to sum to 0. Now when I do the math, I'm just going to ignore units so that it looks clearer. All right, this first term becomes 1265 when we do the math. The next term becomes a negative 3515 times C to get to 0. Remember that we're solving for this variable C in this problem. What we're going to do is add 3515 times C to each side, and the result is that 3515 times C is equal to 1265. So we can get C as 1265 divided by 3515 to get 0.359886. The units are going to be calories per gram degree C. With the appropriate number of sig figs, this becomes 0.36 calories per gram degree C.